Hello there. Today we're going to take a look at the IoTEdge SoC FPGA project. This is essentially an Azure IoT Edge module that allows you to control an Intel Cyclone V SoC FPGA device using an Azure IoT Edge deployed module. So you might be wondering, what is this all about and why would I want to do this? Well, it can allow you to remotely configure your FPGA so long as you have an associated RBF file or raw binary file that contains your circuit design on it, and it will allow you to load that in dynamically to configure your FPGA essentially at runtime remotely through a cloud deployed mechanism. And so before we get started, I'm going to give a quick little background on what this Azure IoT Edge service is that I'm employing here. So this is a service that's offered in Microsoft Azure that allows you to specify code in the form of these containerized modules that will run on IoT devices. So once you have a module deployed to your device, it'll go ahead and spin up there, and it will remain up because of the IoT Edge runtime, ensuring that its desired configuration is always running. But it goes a little bit further. It can also do some cool things like report telemetry back up into Microsoft Azure. And it can do this even in intermittent connectivity scenarios. So you might have an IoT device that's deployed on a boat that loses internet connectivity at some point, and whenever it goes back onto shore and gets that internet connectivity, it'll go ahead and take all of those cached telemetry messages and get those up into the cloud with the appropriate timestamps. So it's a really, really cool service that can allow you to really supercharge any solutions that you might be deploying into edge environments that might not always have 100% connectivity to the cloud. So what's really great about this is since we can deploy arbitrary modules down to a device, if we have a way to configure an FPGA device utilizing one of these modules, we can essentially remotely configure our FPGA hardware at runtime utilizing one of these modules. So you'll see here I've got the GitHub repo for IoTEdge SoC FPGA opened up. And just to give you a really quick diagram on how this works, within Azure, we're going to create an instance of an IoT hub that contains IoTEdge services, and we'll build a module that will deploy our arbitrary RBF file down to the Intel Cyclone V chip and configure it at runtime through the module. I do want to call out that this user in Hasman has created a portion of this code that I'm leveraging here that allows us to configure it from Linux. So I do want to give him a shout out, as his code was very, very useful in the creation of this module. So let's go ahead and go through a quick demonstration of how to utilize it. So I'm going to open up the Quartus Prime software here, and I've got myself a very basic VHDL file here that's essentially showing how to create a simple XOR gate. So this is going to output high when only one of the inputs is high. If they're both low, it'll output low, and if they're both high, it'll output low. So we're going to take a quick peek here at the pin assignments that I've assigned here, and you'll see by looking at the specifications, the output to pin W15 is going to be one of these LEDs that's located here on the device, and my inputs will be controlled by these switches here, the physical switches SW0 and SW1. Now what we're going to do is we can go ahead and compile this project, and I've already gone ahead and done that. And this is going to spit out an SFO or SOF file, I'm sorry, and we're going to need to convert this to an RBF file. Now the name is important here because the IoT Edge module always expects that the RBF file that we load is named FPGA _config _file.rbf. So I've already got that set up here. And the output of my compilation process has created this file called light.sof, which is essentially the representation of my XOR gate that we can load into the FPGA and then control with those physical switches that we just pointed out there. So I've got this configured here to output a RBF file, and I'm going to select the light.sof file here and click generate, and this will create this FPGA _config _file RBF. So excellent. Now what I'm going to do is I've cloned down the source of the SoC FPGA repo, and I've gone ahead and copied in the FPGA underscore config file.rbf. And I've sort of overwritten the one that was already there. They effectively do the same thing as this code does ship with this compiled RBF for the XOR gate. But if you were wanting to use your own RBF file, simply through the process I just showed there, create your SOF, convert it to an RBF, rename it, and then replace it here. Now I'm going to show you how we can actually deploy this over to our device. So IoTEdge is controlled through this thing called the deployment template.json that specifies what modules we want to run on our device. I'm doing a few special things here. I've got myself this module called DE10 Nano RBF Loader. And what that's going to do here, it's going to mount in the device of /mem, because we're going to actually enable the FPGA programming by interacting directly with the physical registers through the HPS that's on board on the device. And so I've also added in here the sysraw IO capability, and this is going to allow me to perform the IO functions necessary to enable that FPGA from within a running container on the device. Now, this does assume that I have IoTEdge running on the device, and there is not a supported off-the-shelf OS that you can just pull down to do this, but if you do read in the GitHub repo, it'll show you how you can build a compatible OS from source that will allow you to run this on there. So once you've got this set up, I can simply go ahead and right-click, and I'm going to do Build and Push IoTEdge Solution. And so this is actually going to build my module using this multi-stage Docker file here. And just to walk through what this is doing, it's pulling down Intel SoC EDS software because that's going to be needed to compile in Hasbun's DE10 Nano FPGA Linux config. So it's going to pull that down, install it, and this could take a while on the first execution. Mine is cached because I've already ran it, but do beware that this could take a few minutes if you're running it for the first time. And it's going to build out his code here, this main.c and main.h, and we're then going to copy that into our IoTEdge module. And then if you look inside the code for the IoTEdge module, essentially what we're doing here is calling into that compiled program, the FPGA RBF load. We're simply spawning that off as a new process using execve or execve inside of our module. So once we've done that, it'll go ahead and spit out a Docker image that it's going to push to a Docker repo that's under my control. If you do need to change that to one that's under your control, simply head over to the module.json file and update it appropriately. And it's also going to spit out this file underneath the config folder called deployment.arm32v7.json. And so you'll see here, this is essentially using that deployment template, it's creating an actual configuration that we can deploy to a device. So getting our code onto the device is rather easy. You can simply right-click, click Create Deployment for Single Device, and we'll select the DE10 Nano device. Now, the reason I'm able to do this is because I have the IoTEdge extension installed for Visual Studio Code. So again, within the README documentation on the GitHub repo, it will walk through where to obtain that. But once you have that, it makes it very, very easy to deploy this code to the device. So I'm going to go ahead and jump into my device, which is running IoTEdge. So we can go ahead and take a quick look at what modules are running on this device. So I'll do a quick IoTEdge list. And you can see here I've got the DE10 RBF loader. It's already been configured and is loading there. And I'm going to go ahead and just look at the output of this particular container. So we'll look there at that module. And you can see that it has successfully started up the FPGA. So that code that it deploys is essentially going to turn the FPGA off and then set it into user mode and launch the associated RBF file. And so we can confirm that over here. I'm going to go ahead and flick on one of my switches, and you should see that the LED is now on this device. And if I switch on this other switch here, it should go off. Because remember, we deployed an XOR gate, and if I switch the other one off, the light goes on. So you can see here, this is a way to deploy really any arbitrary RBF file using Azure IoTEdge. And so you can get all of those benefits of Azure IoTEdge while also being able to have a really nice, cool way to remotely deploy out FPGA configurations to your devices. So I hope that this has been something that you can find useful and perhaps leverage in some of your projects. This has been really fun to work with, and I really like this DE10 Nano device. It's pretty cool. I think there's a lot of really awesome things that you can do here, particularly being able to deploy out essentially cloud configurable FPGA code that can make you do a variety of things that are not possible on other devices. So if you like this, please leave me a note in the comments if you have any ideas on how to maybe improve this or ways that you want to use this in your own projects. Reach out and let me know. It's been a pleasure. So again, thank you for tuning in here, and I hope you enjoyed and learned something.